All right, let's do it here. No, partitions with max min difference at most k. Medium. Okay. Reasonable. You're given an integer array nums and integer k. Your task is to partition nums into one or more non-empty contiguous segments such that in each segment the difference between the maximum and minimum elements is at most k. Okay. Return the total number of ways to partition nums under this condition. Every possible way to partition it such that the partitions are non-empty contiguous and within k. Okay. Alright, before I forget, I'm going to because I have forgotten and gotten errors due to it. Something like this. Okay, so what does this mean? I think I understand what it means. Let's just go through some examples. So the maximum minimum elements is at most k, and I see. So I think it's always possible to break it into single segments that are single length, single elements, because then the maximum min is going to be the same value, and this difference there is 0, so it's less than k. Yeah, so everything's the same. But if it's, or everything's one-sized. If it's two-sized, or if you consider possibly adding two-sized stuff, 9 and 4 would never work because that's not within 4, so it has to be 9 by itself. 4 and 1 could work, 4 and 1, 3 could even work, 4, 1, 3, 7 doesn't work because the 1 and 7 is too far apart. Okay, so I think this is going to be something along a sliding window technique. I can imagine that if you were to extend out a particular segment as far as possible, so the 4 could extend out all the way to the 3. Then obviously every sub-segment or sub kind of partition within that would work. So if you send out 4, 1, 3, then 4, 1, and 3 by itself would work. 4, 1, and then the 3 would work. Or like 4 and the 1, 3 could work. And then 4, 1, 3 as a single segment would work. So maybe some sort of sliding window technique where the window is equal to the maximum partition where min, max are within k. And then within k difference of each other. Every subpartition of that window should work. But then the thing with extending it too far, so if you have an extra addition to the window, that kind of invalidates the window, invalidates this invariant of the window. I guess I can call this the window invariant. If you have an extra element that invalidates it, then how would you handle that? You just slide the right side of the window until the invariant is wrong. I see, yeah. So it is going to be adding the extra element to your window and then closing your window such that the invariant now becomes true. So if the so something like Windows 9, and then you try to extend to 9.4, that's going to make this thing incorrect. So then you need to close the window, close out the 9, so it's just the 4. Then you analyze how many things are possible with that. You extend out the 4, extend out to the 1. You don't have to close it at all. Extend out to the 3. You don't have to close it at all. Extend out to the 7. And then at the 7, you have to remove stuff on the right left side of the window. You have to remove the 1 to the 3, 7. Okay, so it's just this is just straight sliding window. Okay. Well, oh shit, that's not necessarily true. So that's not true because your window is just the number of partitions on the left side, the number of ways to partition up to a certain right index. So then I think you need to do on the left side, you have to do the kind of remaining portions. Because if you do, like, let's say 9 by itself, then you need to multiply the number of ways that you get up to this thing, up to this value of 9, index 9, with every way of partitioning 4, 1, 3 such that they're working. So I think I think I have to do both sides. I think I have to do one direction going left to right indexing, sliding the window left to right, and then the other way going right to left, keeping track of maybe as I go left to right the number of ways to get to a certain index, the number of partitions that you can kind of combine up to a certain index, and then combine that with the number of ways to get to that other part, to that same index going from the other way, and then you kind of multiply them. So like if I get to this index, let's say this index is 2, with like say 10 ways, then I need to multiply that with the number of ways I get to from here to here, from index 11 to, or index 3 to the end. I wonder. Is that correct? No. No, actually maybe I can just do it in one pass. Alright, I'm going to try to do it in one pass. Let's try. Okay, so left index is equal to 0. The left is left for every right. I probably need an array to keep track of things. Well, whatever. Let's try this. For every right index in range n, where n is the length of the numbers. So I need to add right element to window. So I need to keep track of them. Track of the current min and max of the window, right? So I think I need to current min is going to be equal to nums at 0, which will also be equal to the current maximum. So that when it first opens the window to include the first value in the array, it's going to always work. It's always going to say that's within k of that value. Okay, so here I can say let's try to append this thing then. So let's just consider a random case where there's already something there. So let's say the current min is 5, the current max is 8, and the current value is 10. So as long as I think I need to update the current min and current max. If this value, let's say our value, is the nums at the right index. If the R value is greater than the current max, then current max is going to update. Do I need to update both? This is else if or just else. I think this is just else. No, it's else else. Or it could be just another if rather than else if. I think it's just fine if I do an else if R value is smaller than current min equals R value. Then if the current max minus the current min is greater than k, then I need to close this. I need to close this. Okay, now I see what difficulty is. When I close the window, I need to know when I remove a value that is a min value in the window. Like let's say the window is 4137. 413 is a valid window. The right index is at 3. And then when I extend it to be 4137, I would remove the 4, I remove the 1, and then somehow I would need to know that 3 is the new low when the 1 is removed. So maybe I need like a heap. Otherwise, I mean, it could be like 4, 1, 5, 3. So the 3 doesn't necessarily need to be the next thing. So I don't really know where buried within between the 1 and the 7 where this new low is. So I think I need a heap. Well, if I need one heap, I need 2 heaps probably. 1 heap for the low and 1 heap for the high of the current window. Is that correct? But then it comes down to whether or not then it comes down to how you remove stuff from the heap. Because when you remove stuff from a heap, it's not easy. You can always check for the low or high of the heap, but if something becomes removed from the heap, then you need to keep track of like a set or dictionary of counts of things in the heap. That's a bummer. That's a bummer indeed. Remove the 4, remove the 1, 3 to the 7. The low from the remove, and then you remove the low. Now you have to know what the new low is and verify that new low is going to be within K of this thing. The same conundrum. I guess I just need more practice with this type of issue. Is this fast enough? Remove stuff. Remove stuff. I'm gonna say, I guess I can just say counts. This should probably just be like a default dictionary. Yep. Default dictionary of ints, where it's gonna be the key is gonna be the value. Key is the number in the array, and the value of that key is going to be frequency of that number in the window. Yeah. Okay, so if, I guess this should be while, huh? While current min minus current max, or current max minus current min is greater than K, then this is going to need to remove from, this is going to, actually I think this needs, I just need an and. Okay, I think I need a min heap and a max heap. Yeah, I need to start with right is equal to next one, because probably I just want to say min heap is equal to the first value. What am I doing here? This should be not min at 0, this nums at 0. Min heap is going to be nums of 0. This is going to be, needs to subtract the smallest, which is the default. This needs to be nums at 0, the negative of that, so this is going to be descending order heap, or not descending order, track highest. Track highest is going to be the largest negative, since that's the only way it works. Heaps are always kind of ascended, is always going to give you the min value. So if you want the max value for a heap, then you need to put in the negative of the values in order to get the largest to become the smallest in the heap. Track lowest, track smallest. Okay. Right, so if current max minus current, so things I need to just always remember that I will need to do, I need to eventually I even need this because then the current heap is actually these things are just added to the heaps, right, rather than tracked as variables. Yeah, this is supposed to be added to the heap. So min heap needs to heap q dot heap push onto the min heap the current R value. Heap q dot heap push onto the max heap negative of the R value. And then something like current max and current min needs to change to while heap q, I think it needs to be like a while true, to be honest, because I need to validate the start of the heaps continually, because it could be an outdated value at this point or at some point. So ensure the top of the heaps are valid. Non-zero count. So I think I can say while there is a min heap and min heap at 0, that value, that number, the counts of that number is equal to 0. Then min heap heap q dot heap pop min heap. Same thing while max heap and counts of the number, which is max heap at 0 at the top of the heap is 0 heap q heap pop max heap. Alright. I wonder. Do I need to track the value and the index of that value? Because when I pop a value off the heap to see what I need to remove, is that the way that works? So 7x extended. What am I doing here? 7x extended. 7 is the new high. Variant is invalidated. Then I would need to close the window on the left side, so I would remove the 4. I'd check to see if the 4 is the 4 is the min. Yeah, I'd check to see if the 4 is the min. If it's not, see if the 4 is the min. If I look at the heap, the min heap, to see that 1 is the lowest, so therefore 1 and 7 is too far apart. So I would need to go through the whole thing I would need to go from the left side up to where the 1 is. What if there's multiple 1s? Maybe it needs to be adding a tuple that is the number and the index of that number. So you can see that 1 is at index 2 on the min heap. My left index is at index 1. I go from 1, remove everything up to 2, changing the counts, and then I reevaluate whether or not the top of the min heap is still far enough. It's now working with the max value. Actually, I don't know. Where these things are. Okay. I think I need to know the indexing. What is going on? This might be too much information. So I keep on going. So while the top of the max and top of the min are too far apart, keep on going on the left side. If it matches either, if the left side matches the min, then changes counts as it goes along. Skips things that are incorrect. Changes counts as it goes along. Skips things that are incorrect. There's so much indexing here. There's multiple 1s and there's multiple 1s. I'd be removing 1 at a time, the 1s. Yeah, I guess maybe I don't need it. I don't need to know. The indexing. Indexing might be. I mean, I'm guessing the indexing just doesn't hurt, but I'm going to try to do it without it. Question is if I understand what I'm doing at all. Okay, so here just validating that the top and the smallest and the largest are actually valid things that have frequency 1 or higher. Okay, so I think I can do something like while min. Okay, so if min heap at 0 plus, or let's say the difference, just do that. max heap at 0 minus min heap at 0 is valid. Let's say it's less than or equal to k. Just break the loop. At this point, maybe I do just one iteration, just remove one element. So let's say the left value is equal to nums at left, and then what? I need to remove that from the counts. Count of left value is going to decrement. Left needs to increment its index. And then I also need to remove that from the top or the bottom of the heap if it matches. So if left value equals, this is the wrong, this is a negative number. So negative this stores a negative number. If left value is equal to negative of max heap at 0, then I'll do a heap pop, heap q dot heap pop max heap. If left value is equal to negative of, no, just min heap at 0, so it's the smallest, heap q dot heap pop min heap. There's a lot of conditionals here. I think this is strictly necessary. And then I just redo that whole process again at the next index. Will min heap ever be 0? Empty? I guess probably not. If I initialize it to some value, it should never empty itself. It always includes the R value before it removes things. So I think I don't need to check that it's ever empty. If it's empty, then something bad has happened. So while there's invalid stuff at the top of the heaps, remove those invalid stuff. Then check to see if the valid top and bottom, max and min, is within k. If it's within k, then just stop the loop. Get the current left value of the window, remove that value from the counts, increment the left index. If the left value matches low, then remove it from, or matches the high, remove it from the high, matches the low, remove it from low. Okay, at this point it should be the window is now valid. So now I should be able to use left and right indices as the maximum partition here. So what is this going to work? So 9, there's one way. So how is this calculation going to work? So if I have nums is equal to 94137, the implied calculation is there should be one way to get to the 9, and then somehow the 413 needs to be maybe I need to just do a split right there. Maybe I need to do some sort of array of partitions at each index the number of ways to get to that index with some number of partitions. So up to 9 there should be 1. And then if I include the 4, it doesn't extend out, so I think it stores a 1 there. When it does the 4, 1, then that means that the partition size is 2. 4, 1, 3, the partition size there's 3. So 3 ways. Well, the length of the partition is 3, but how many subpartitions there? I think it might be 2 to the n minus 2 to the length minus 1. So, or is it n squared? So it could all be 1s, it could be 2s, or it could be 3. It's n squared. So here, if its length is 3, then it should be 6 ways. No. 3 times 2 divided by 2. 3 ways. If it's 2, it's actually 3, no? 1, no, 6, 6, 6. There's 3 1 partition. There's 3 1s, 2 2s, and 1 3 there. And here, actually 4 1. There's 3 ways: 4 1 and 4 1 combined. And those 6 ways would need to kind of multiply with the 1 way here. 1 way to partition the 9. And then if I add the 7 doesn't work. Or, no, so if I extend to the 7, that means what? 7 could be, oh man. The 7 by itself could work with anything that ends with a 3. The 7 3 could work with anything that ends with the 1. Oh boy. Oh. Oh my god. Sacre bleu. Sacre bleu. Okay, the maximum size of the 7 is going to be a length 2 partition, 7 3. So in theory, ending with this thing is going to be 3. That's the maximum length. Maybe I can do this separately. So like the longest thing that ends with a certain index is going to be 1 here, it's going to be 1 here, it's going to be, okay, yeah, this is max part length. Should be 1 1 2 3 2. Maybe I just store that and then I try to do a calculation based on that. Okay, so if I have that, and eventually maybe it can be condensed into one pass, but if I do these as separate passes, then how do I calculate this? Wow, there was only 7? Or there was only 6 ways? Okay, anyways, how do I do this calculation? So up to 9 there's 1 way. If we're doing 9 and 4, there's just 1 way really. If the array was 9 4, there's just like 9 and 4 as separate subpartitions or separate partitions. 9 4 1. So this 1 could be part of 2, or it could be by itself. It could always be by itself, but be part of 2. Interesting, interesting. How would you calculate that? So ending in the 1. So ending 1, it could be at max length 2. So I think maybe if I consider this as some sort of prefix sum, consider this as part of some sort of prefix sum, the length have something to do with the previous number of prefix sums? I don't know. So this is maximum number of ways to partition up to index n, index k. So the maximum length here is 2. So if it's just the 1, then it should just copy over the previous maximum length. And then if it's the 2, then it should copy over the previous, it should add the last 2 elements here. Yeah, so adds 1 plus 1 gets 2. 3, it needs to add the last 3 elements. So it needs to add 2 plus 1 plus 1, so that's going to be 4. And then 2 needs to add the last 2, so it adds the 2 and 4 and gets 6. If max part length at k equals, okay, say parts at k equals sum of previous k minus k entries in parts. Yeah. Sum of previous k, no, sorry. Max parts at k equals sum of previous max part length of k entries in parts. So if I'm dealing with this index, I'm looking at this value of 3 and adding 3 values, last 3 values from here. Okay. There might be some off by 1 indexing within that statement, but it's roughly like that. How do I find the last for a certain array that I'm creating? How do I find the last k sums? So like 1, 1, 2. Like I guess it's always going to be smaller. It's always going to be 1 more or less. It's not going to be some jump from like 3 to 10. Like it's always going to increase by 1 or decrease by a lot. Guess I could do another sliding window. The window extends. Sum of the 1, sum of the 2, sum of 3. If it removes, then it removes from the right side of the window. Okay, so that means I just need, if I were to try to decompose it like I am considering here, I need to have two separate arrays. And I just need to keep track of the length of the window here. So max partition length is equal to empty array to start, and I think after this it should be max partition length is gonna append right minus left plus 1, because it could be at the same index. Yeah, right minus left plus 1. Alright, let's go ahead and just print that out. See if that part is working. Or let's see the crashes here. I'm sure there's some. Index out of range. Okay, so line 26. Thought this would always work. Counts at max heap of 0 equals 0. Or counts at min heap equals 0 of 0. Why would that go out of bounds? Because that means that the heap is empty. The heap should always have at least one element, which is the R value. Wait. I think actually this should start with empty. No. That should start empty because I am going through all the indices starting with the first value. Okay, let's double check that still occurs to crash. Okay. So the right value, heap push, oh mother, I forgot to increment the counts. I'm so bad. Counts of R value increments by 1. Jesus. Okay, that didn't actually affect this error, or so it now crashed at the max heap rather than the min heap. Oh, let me think. Counts of R value. Yeah, so why would that be? If the difference is less than or equal to k, stop. Nums left value decrements, left side increases, counts of left value decrements. If the left value is equal to max negative of the max heap, I think I see it. Yeah. It's because this is doing it in asynchronous timing. If the min and the max heap have the same. Actually, how is this working? If the min and max heap have the same value, maybe somehow. It only has the same value when it's like a one element in the window. And then if you have a different element added to the windows, or to the window added to both heaps, it shouldn't really. While counts of min heap equals 0, move it. You move that count until you get to something that's actually there. Okay, I think I need to actually see what's going on. Print left, min heap, max heap. Okay, so first pass. Is my logic for this thing wrong? Negative of max heap. Max heap is -9. So negative that is positive 9. 9 minus 9 is less than or equal to 0. Less than or equal to k, so it breaks. So what the heck? Okay, let's go ahead and print okay there. I'm guessing it crashes before hitting that okay. Heap. Okay, fine. Let's go ahead and also print out counts. Okay, there's 1, 9. Oh, my indexing is wrong. Or I need to actually negate the value I'm getting from count set or from max heap. Gosh darn it. Okay, I think that was the issue. Okay, 1, 1, 2, 3, 2. That's exactly what I was predicting. 1, 2, 3, 2. Okay, so then I need to just now work with the parts. Make the parts array. So the parts array is going to be empty to start with. It's going to be the sum of the previous parts value. I guess I could do a deck. I could also just use parts and just index into parts. Okay, so let's say the left side is going to be at 0, and the current sum is going to be 0. And then for every right index in range of n, which matches the length of max part length, I'll get the, actually maybe it needs to always start with 1. Maybe parts just always starts with 1, and then I can go from 1 to whatever. Because I know that that's just how it works. Okay, so everything in range of 1 to n. So I take the window length as the max part length at this right index. So this window length is going to be 1. And that means I add the previous 1 values. So this only occurs if it's less than. Because then it's 2, then it's going to be let me think. If it's 1, so if it's 2, then the previous sum is 1. If it's 2, then I should add this 1. So I should add maybe I need a current length. You know if I'm increasing the current length by 1, then it just adds the current value to the current sum. If it's extending it by 1, then adds the current value being the last value. 1 plus 1 extends it, then adds the current. So this is 2 plus 2. Okay. If the new window length is equal to the current length plus 1, then the current sum should increase by the last thing in the array parts at -1. Else, well, is it ever not gonna do that? It should always do that, right? If the current sum is 2, then it's adding so it added this 4. Should the current sum is appended by that? Does it modify the current sum? It appends it, but does it modify it? Because once it appends it, like the current sum of 112 is 4, it appends the 4, but should that also change the current sum to become 8? I guess it doesn't really matter. Just need to be consistent with it. I mean, it's always going to be part of the answer. So if this thing's a 1, then actually if that thing's a 1, then yeah, then I just do 4 right there. Okay, so maybe I just always assume that I add the current sum, the appended value to itself, so that means I kind of double the current sum. Does it always double for whatever the window is? It's appended. So the window is 4 times 4. Nasty, nasty, nasty. Okay, so the current sum should initially start with 1 then. I don't think I need this current length. It's implied with left, I guess. Okay. So, actually I do need the length part. So if I get a 1, the right minus left is 1. So that works out. So I think it should be something like while W length is larger than right minus left. So if this is actually, let's say right minus left is size 5, the window's size 5 previously, the current thing is 2, then I need to remove stuff. Remove stuff from the right side, from the left side. So it's going to be current sum minus equals parts at left. Remove that from the summation. Left plus equals 1. And then keep on doing that until it's appropriately sized. Okay. And then whatever the current sum is, it now appends. Parts append current sum. And because it appends the current sum, then it should double. Yeah, okay. Answer, or answer is actually the last entry in the array. Out of bounds. Out of bounds. Huh, okay, let's go ahead and just print out stuff. Print out the stuff. Index out of range. Really? So it immediately goes out of range. Oh, is it greater than or equal to? Wait. The level length is 2. While it's bigger. So this is at the very start. This is the first pass. Right should be 1. Max part length should be 1. No? What is going on here? This is error on this other one, on the other test case. 334. So the maximum length here is going to be 0. Interesting. Or maximum difference is 0. So it's 1, 1, or 1, 2, and 1. Okay. That's fine. So 0. So the indexing is 0. Left is at 0, right is at 1. The maximum length is 2. The maximum length is 2, so it includes both. Okay, that's... Am I miscalculating it? It should be W length minus 1. Okay, so nums equals 334. Max part length is 121. Okay, parts. So just one here. So this is 2. So it's the sum of the last 2. There should probably be implied 0, I think. Yeah, let's have implied 0 maybe. 0 plus 1. No, it has an implied 1. Interesting. 1 plus 1 is 2. So it's an implied. There's an implied precursor 1. I guess maybe that makes sense. Maybe that was why I had this weird starting issue. Okay. So it includes 1 here. That means I need to start right index 0. Right index 0. I think that also means I need to do like right minus left. Okay, let's go ahead and just see if that works. Nope. Wonder if that, no, it just crashed the very first one. I think previously it worked on the first example, first test case, but now it's not working. Alright, so let me think about this. Parts initially starts with a default of 1. Okay, max part length is 1. Here it's 0, 0, 1. Zero, zero, 1. Left is 0, right is 1, W length is 1. And it crashes. Parts at left. Why is that out of bounds? Parts at left should be parts at 0, which should be 1. While W length is greater than, oh, it's going to do it one more time, isn't it? W length is 1. Now right minus left is negative 1. So shrinking. So it should probably be right minus left, W length plus 1. Let's see, this is normally supposed to be too big, or let's say this is normally supposed to be too big and then you shrink it. But you don't want to shrink it if it's already fine. Oh my god, my logic is just so bad today. Right minus left is 1 minus 0, which is 1. W length is 1 plus 1 is 2. 2 is wow, this is too big. W length it should be, wow, it's too small. Right minus left is naturally increasing value. given that left is stationary, right is an increasing index, so it's naturally increasing. But right here it encounters something that makes it smaller. So you have to decrease it, removing the stuff on the left side. Current sum minus equals parts at left. So then the next calculation, right minus left, should be, that makes it a smaller value. Is it supposed to be this way? Wow, this thing is too big. Yeah, I flipped my fucking signs. Wow, this thing is smaller than that. Okay. Close, but no cigar, sir. Okay, I think I need to see what the parts ends up being. I wonder if I need to go back to my previous thing of, no, whatever. One, 2, 4. 8 is wrong. 1, 1, 2, 4 should be 6, and then it shouldn't even need one more iteration. Alright, let's try it without this. Oh no, this is gonna crash. This is gonna definitely crash. Oh, didn't crash. Well, didn't crash. This thing ends up being short. No, this ends up being correct. 1, 1, 2, 4, 6. 1, 1, 2, 4, 6. This one ends up being 1, 1, 1. 0, 1, 2. Yeah, I think this is just, this adds 1. We should add 1 plus 1 there and get 2 here. Add 1 plus 1 and get 2. Left index is at 0, right index is at 1. Right index, if it's 2, 0, 1, 2, 0, 1, 2. So the current sum needs to add that's on the first pass. Well, I think maybe let's try doing it like this. Okay. 1, 1, 2. Still not even getting this second one correct. No, actually it is. No, this is 3. This part's right. 1, 2. But then this is 1, so it should actually just have 2 here. Interesting. Yeah, okay. Okay. It's not appending, it's not doubling. Okay, this thing is wrong. It's not current sum times equals 2, it's current sum plus equals the last value. Current sum plus equals whatever you appended. Well, if you append the last thing to the last value, then that's going to be doubling now. Oh boy. So this is, okay, 1, 2, 4, 8, so 2, 4, so 3, that's the 1, 1, 2. Actually, I'm not sure how you get the 14, to be honest. Alright, so let's go ahead and say here. Oh, I'll just go back to times equals 2, even though I know that's wrong. I guess I should have probably figured that out, given that it just is that. Man, this should not be this hard. What the fuck? So I have to just erase everything and go back to the start. So W length is 1. So if the W length is 1, it's the sum of the last 1 elements in the parts array. Sum of the last 1 elements. The right is index 1, the left is index 0. W length is going to be the sum of the last 1 element. Sum of the last 1 elements. Maybe I should have current sum be 1, but parts just be empty. Current length be 1, but parts be empty. Yeah. Let's see maybe how the logic there might be correct. 1, 1, 1, 2, 4, 8, 1, 2, 3. Okay. Left is index 0. Current sum is 1. Doesn't feel right either. So 1 means that I append 1. 1 means I append 1. 1 means I append 1. And 2 means I should append a 2. There should be 2 here. The 1. Wait, what's the correct play here? It should be 3. 1. Max length is 2. Max length is 2. So I should be adding the last 2 elements, but the last 2 elements is just 1 and it's 1. So maybe there is an implied 1 here. Otherwise it shouldn't be adding that. Should be adding 1 to nothing. What if it was something like this? If it was nums is equal to 333. So the max part length is going to be equal to 1, 2, 3. So the parts should be like 1, something that's 2 length. So it's either 1 here, if it's 2 length, then it's either 1 here. Oh my god, my brain is fried. 1. Alright, yeah, fucking test case this. Doubling 1, 1, 2, 4. I'm assuming this is doubling as well, 1, 2, 4, 8. Okay. So 1, 2, 3. Let's say this is the third one. So the sum of the last 2 elements. So there has to be an implied 1 here. But then, and then the sum of the last 3 elements. 1, 1 plus 2 is 4. Sum of the last 4 elements. That's 8. So does it work if I just have an implied 1? So sum of the last 1 element is 1, sum of the last 2 elements is 2, sum of the last 1 element is 1. So it should work if parts starts with 1. Implied right is the index into the max part length, but it's not necessarily the index into the parts array. Index into the parts array is right plus 1. So I think maybe this should be right plus 1. Oh my god. This is not going to be very fast, I don't think, but it's going to be a solution. Man, this was not really a medium. Or at least the way that I attempted to solve this, not really a medium. It's more like a fucking hard. Definitely the one yesterday was. Was the yesterday one a hard one? No, the yesterday was an easy one. Okay, trapezoid was harder. But that being the case, I don't know if I actually want to try to optimize this one. I feel pretty beat up right now. I don't feel very good about how I coded that in terms of how long it took me to fix the logic issues. Like obviously I was going to screw up the indexing when I added this thing, but I just didn't actually fix my code to change my code to take into that account and just hope that it worked, and then had to spend a lot of time trying to find it. I guess, I don't know. I don't know why this thing's actually running that long. Probably, I wonder. So we move up, we move stuff from the top. Pop is invalid, pop is invalid. Pop it if it's invalid. Pop if it's invalid. If it's valid, then check this stuff. Yeah, I think there's some optimization if I were to combine the calculation of the maximum partition length with the actual summation of the stuff inside it. That being the case, though, I don't feel the need to actually create one super loop to do everything at once. It's just going to be very complicated. Alright, this one where I'm fine with accepting this result. Okay, summary. So for this solution, this is again not really optimized, but I'm okay with that. So the summary here is going to be we can look at the above examples to, well, probably want to extrapolate or recalculate some of these things. I think it should be 1, 2, 1, 1, 2. So this is the sum of the last one, where the 1 starts with 1. So it's 1, last 2, so this is 1 plus 1, which is 2, last 1, so it's going to be just the 2. And then, yeah, okay, so look at the below examples to piece through the logic, but in general, the steps are A, compute an array, I'll call this max part length, where that gives the maximum gives the length of the longest window that ends with index k, where array at k equals the length of the longest window that ends at index k. Where max and min values in window are have difference less than or equal to k, less than or equal to, oh, k is the other thing, isn't it? Alright, array I and then b using max part length, compute parts, compute an array parts where parts at I equals the sum of previous max part length at I entries in parts. So for example, if max part length is at I equals 3, sum last 3 elements in parts array and append that to array. Logic there being that if you know a certain partition length, say the partition length is 3, so that means that here you can extend 3 all the way back to the 4 and have any partition within that work. Then that means that you could have this 3 by itself, or this 3 and, well, 3 by itself means that the number of ways that you partition up to the 1 would work, because then every way that you partition up to the 1 could be added with the 3, added with a single partition of 3. And there were 2 ways to partition up to the 1. And then any ways that you can partition up to the 4, because then that means that 3 and 1 is one partition, and all the ways that you partition up to the 4, there was one way there. And then every way that you partition up to the 9, because then 4, 1, 3 is one partition, and then 9 is the other partition. The ways that you partition 9 is the other ways. So the sum of those 3 values, or the sum of those 3 values, so it's going to be 2, 1, 1, 2 ways to partition up to the 1, 1 way to partition up to the 4, 1 way to partition to 9. So there's a total of 4. So there's 4 ways to partition everything up to the 3. The 7 had 2, so max length here is 2. So the sum of the last 2 elements, so 4 and 2, 4 being like it'll be all the ways to partition to 3 and the 7, 2 being all the ways to partition up to the 1, and then the ways of partitioning to 7 and 3. So it would be, or plus getting a 3, 7 to work with that. So yeah. And then return the parts at -1. For calculating max part length array, use sliding window technique. Keeping track of counts or frequencies of values using a default dictionary. And then if the added value to the window also keep track of max and min of window using heaps. for iterating, or when iterating over values, basically a right side window. Add value to the counts/heaps. Check if the invariant is broken. Basically, the max minus the min is greater than k. If so, remove values from window until invariant is restored. Then add the size of window to the max part length array, which is kind of, yeah, that in itself is a medium problem. Maybe this is kind of a difficulty creep, but yeah, max heap, min heap, right indexing, add to the window. This is all kind of removing stuff to make sure the window works again. And then restore. Window invariant. Remove left value if needed. And then there was the other part, which was too tedious to figure out. Okay, anyways, yeah, this technically was a real thorn. Alright, time complexity looks to be O of n, where n is the length of the array. Could have made a more optimized solution with a single pass rather than multiple passes when decomposing the problem into multiple arrays like I did. Space complexity, this can be O of n to keep the to construct the max part length array and the parts array. All right.